try to get through the general features of the fossil record today, if possible. Would you mind closing the door there? Great. I don't want to. I'm told I'm kind of loud. I get that all the time.
History class. Can we shut the door?
Can we just be quiet and listen to Cartwright's class?
Not if you're loud, you just have a voice that carries.
Yeah. So we talked about some artifacts in the fossil record that apparently are human in nature. And again, my personal favorite one is Malachite Man. We may spend some more time studying that one later on. But right now, we got to get to my personal favorite part of this PowerPoint, which is the physical evidence. Now, I've tried to make the case that intermediate forms are not really all that, right? I'm going to argue that they're evidence that God used evolution to create, or that God doesn't exist, or whatever. I'm gonna have to call you on that. I don't think they're that good of an evidence. Okay? I'm not an expert in anatomy, so maybe I don't know what I'm talking about. I do know something about geology. Okay, so here's the thing: evolutionists, and especially evolutionary geologists, used to teach. Not anymore, they don't, but they used to teach the layers of rock form, and that therefore the fossils found within these layers also formed over vast periods of time. Okay.
You didn't sound like an old evolutionist. You sound more like Gollum.
Start with us. All right, watch us. Are we wrong? Sorry. Okay. I'll behave. I promise.
We need to have a whole class just.
Okay. So we need to have. We need to have a talent show, like all the teachers. The what? Okay. So science has not been kind to this idea that rock forms slowly over millions of years. Okay. But first, a word from our sponsor. We got to understand that one of the original two pillars of evolution, so-called, is the fossil record. Okay, the geologic column. All right, an imaginary order of the various eras of time. The fact, and it is a fact, that forms of life in these eras were very different and are very different from each other, was one of two reasons why Darwin extrapolated what he saw in the finches over eons of time to get macroevolution. And he knew that that was kind of a shaky foundation. As we have discussed, Darwin wrote 2 chapters in his original book on the origin of the species about all the reasons why he might reject his theory, because he knew it was on a very shaky foundation. Okay, so the geologic column is half of their argument. All right, in some respects. And if you went to a government school, this is the kind of thing that you would see. And your teacher would be like, so we only find trilobites in the Cambrian layer, and then further up we find some fancy shellfish. You're so shellfish. And then up higher than that, we find the placoderms, which is the plated fish. They have armor on them because that's how they do. Okay. And then finally, life evolved to crawl up on the land, and it crawled underneath a rock for millions of years. And then it grew some hair.
Cool.
And it crawled up a tree and ate bananas for millions of years. And then it got a haircut, went to JCPenney and bought itself a suit. And here we are. So that's the geologic column for you, okay? So here's the thing. This picture exists in every textbook in America and every government school. All of your peers are being taught that this is just watertight evidence for evolution. Like anybody with a couple of brain cells to rub together, you're going to see some sparks come out of their ears, but they acknowledge that this is just a bulletproof case for millions of years and molecules to man evolution. However, that's the only place the geologic column exists. In the textbooks. It doesn't exist in a little place I like to call the real world. The Grand Canyon, for example, has, of the 13 layers, 5. The first, the fifth, the sixth, and I want to say it's like the 8th. Is that right? Parts of the fourth in there somewhere. The thing of it is,
Wait,
it only
how is
has.
the 8th layer in there, but the 7th,
Yeah,
6th,
they're
6th.
not all in order. That's the other thing, is they don't always occur in this nice, neat little order they've got for us.
Why, how is, if, then that would just be the 5th layer if it was like, oh, here's the 3rd.
Well, it depends
4th.
on who's counting, though, doesn't it? Okay,
My
so
dad used to work for an oil company, and they had to see which layers were drilled in, all the different names, like for
Devonian, Ordovician,
he had to study
Florian.
all of that.
And you know how they tell which layer of rock they're in, right? By the fossils they find there. So you know you're in Devonian rock when you hit a particular type of shellfish.
But you never find a T-Rex in your ground.
Well,
Because it's not a specific layer.
you wouldn't find T-Rex out, lollygagging around 200 foot underneath the ocean either, right? So would you expect to see one down there in the fossil record? No, I wouldn't expect to see them down there.
They could eat whatever they want.
Well, sure.
They can't.
Dude, their arms are like this. You think they're gonna be swimming around? Just trying to stay afloat? You can't even put floaties on, right? So, I mean, this is a problem for them. So this graph is basically a lie. I'm gonna call it a lie. I don't know. It's misleading. Okay. Yes, these layers exist, but they don't all exist in the same place, and we find nothing like a complete layer, even just one of them, anywhere in the world. Okay. So it doesn't exist. Nowhere in the world do we find a complete geologic column. It's true that we find different layers. It is true that they, emphasis on the word, generally appear in a particular order. But in the Grand Canyon, for an example, you only have about 4.5 of the 13 different layers, and only a subset of them. Okay, so it's not like we find all of the Cambrian layer there, even though it's 1,000 feet thick. That is not all of the Cambrian layer. I know, right? So, the chart we saw was actually put together by biologists who are experts in macroevolution, not by geologists and not by paleontologists. Although they use data from geologists, so maybe I'm splitting hairs over this. Okay. Fossils we see tell a different story than the one presented by Darwin and the others, yet they have not updated their chart to reflect reality. Darwin argued the missing links would be found, the spaces would be filled in as more fossils were uncovered, and this is not the case. So, a couple of problems with your little geologic chart. First of all, we have this thing we call the Cambrian explosion. Okay. The lowest layer we find fossils in. Now, we do find some fossils below that. They're usually bacteria or worms, and you can ignore those as far as I'm concerned, okay? The first meaningful fossils are found at the Cambrian layer, all right? It contains 35 out of the 40 phyla of animals. So, you're looking through the fossil record, and you see no living things, nothing, this is bedrock, granite, oh look, a worm. And then everything is right there in the Cambrian. We call that the Cambrian explosion. Okay. They don't teach you this in the government schools because obviously having 35 phyla evolve at the same time is a bit of a stretch. By the way, I have good evidence that we are now up to 37 or 38 of the 40 animal phyla, including vertebrates, way down there in the Cambrian layer, which again, vertebrates are kind of rare on the bottom of the ocean, but they do exist. Okay. So let's have a look at a comparison between, over here on the left, what the evolutionists would expect. This is called the tree of life, which is hilarious because it represents billions of years of death. Let's call it the tree of death. Okay. And of course, we see up here on the, oh, here's the trees, and there's us, and then there's the apes and the horses, and the reptiles and all this stuff. So we have the, basically the further back in time you go, the more you look like a blob, right? Which is more true for some of us than others. But anyway, so you have these branches, right? It branches off. You get the conifers that branched off from the angiosperms, and You know, you have the bivalves that branched off from the cephalopods, and I mean, as the further back in time you go, the more you just kind of look like a blob, right? Eventually, far enough back in time, the jellyfish and the sponges are the same organism, right? They have a common ancestor. Well, that's not what we find in the fossil record. This is actual data over here on the right, okay? Now you'll notice we find some organisms in Precambrian rock. And where else do we find them? Everywhere. They're all over the place. Bacteria and worms, they're just, they dominate the world. I don't know if you knew this, okay? So they're all over the place. A couple of them go extinct. Okay, so this is what we represent. We go up a certain number of layers, and what do you know? We don't find, for example, trilobites in anything but Cambrian rock, right? A lot of these guys went extinct, didn't they? We don't have plated fish anymore, right? We don't have trilobites. We don't have some of the crazy shelled squids that were swimming around before Noah's flood. So instead of the evolutionary tree of death, it's more like a creationist. We call this a lawn. Okay, this is our lawn over here, and it's been some of it's been mowed. That little thing we call Great Flood of Noah, right? 40% of all the kinds of animals on this planet bit the dust in that event. Okay, so as you work your way up through the fossil record, you see less and less diversity if you're talking about phyla. You do see bigger, stronger, faster, smarter organisms at the top of the fossil record, and that really shouldn't surprise us, right? Do you know how much fat there is on a fish? I keep kicking myself. How much fat is there on a fish? Not a lot. You know why fish aren't fat? They only eat fish, right? So anyway, sorry.
Kind of also constantly like.
Swimming in the water, and there's a good aerobic exercise program. There are some, okay, they have a little omega-3. That's what happens to a fish if you bring it up from like 3 miles underneath the water. And it's actually really cool in its environment. And you bring it up to the surface, it explodes.
Really?
Really, well, that's what happens. Its individual cells rupture. It's not like it's a bomb. It's that it can't take the lack of pressure.
You just bring up, blows up your entire.
Can we have a picture of a blobfish before it self-ruptures?
You'll have to look it up later. Anyway, so my point is that reality doesn't look like this. This is an artist's picture of what they thought they would find, and this is reality. You got way more diversity in the Cambrian layer than we find anywhere else on the planet. And why is that? Eli?
Oh, sorry.
Well, because we believe the original creative world was better, more diverse than the one that we are walking around on today. So let's have a look from Richard Dawkins. You guys know who Richard Dawkins is? One of the most adamant anti-creationist atheists out there. This guy is extraordinarily religious in his fervor against religion. Anyway, he wrote The Blind Watchmaker before I was born, and he actually, continuously tries to break down arguments in favor of creation. And what does he say about the fossil organisms? He's a British guy, so I'm like, and we find many of them already in an advanced state of evolution. The very first time they appear, it is as though they were just planted there without any evolutionary history. Needless to say, this appearance of sudden planting has delighted creationists.
Is he still alive?
Did they say evolution?
Evolution, yeah. Vitamin. Aluminium. Yeah, well, cookie is a crumpet, crumpet's a, anyway. Chips or fries and never mind. We took 2 countries separated by a common language. So what is Darwin, or what is Dawkins saying here? Oh, just ignore the evidence. They look like they were just planted there. They appear as though they don't have an evolutionary history, but of course we know they evolved. So just ignore the fossils, ignore the Cambrian explosion, all that stuff. Just don't even worry about it because, yeah, it's just an appearance of, sudden appearance in the fossil record. Well, I got some bad news for Mr. Dawkins. It's not just that they don't have an evolutionary history. Some of the critters down in the very bottom layer, the Cambrian layer, are the most complicated organisms that there are. For example, the trilobite. Now, we do find the occasional trilobite that apparently did not have eyes. So apparently some of them were designed to live in total darkness all the time. That's very rare, though. So my argument is that most of the pre-flood ocean was shallow enough that it could get light down to the bottom of it. That is to say, 400 or 500 feet deep at the most. Okay, as opposed to the Pacific, which I think has an average depth of 12,000 feet. Anyway, so in other words, trilobites had just a plethora of an environment in which to live, and they have eyes designed perfectly to see underwater. By the way, this is why octopus and squids have those weird W-shaped pupils. They have perfect underwater vision. They can't see very well above water, which is why they don't really come out of the water very often. They can survive outside the water. They can't see very well. Anyway, so
It almost looks like you have like eyes that flies have, like a bunch of dots.
so you'd be forgiven for thinking that this is a compound eye. And it is in a sense it's a compound eye, but it is a totally different system than the ones the insects are using. This compound eye uses crystals to focus light. The math necessary to understand and explain how these guys create images with their crystals was not developed until the 1960s. Okay, they have 14 times the complication that a human eye has. Okay, they have the most complicated eyes of any organism on Earth, and they had perfect underwater vision. And we're talking about the bugs here, guys. Okay, on the bottom of the ocean, 14 times more complicated than any other eyesight on the planet that has ever been observed. And here they are, just right there in the bottom of the evolutionary story. The very first time we find organisms, they are as complicated as anything we've ever found. Okay, this is another type of problem for evolution because we call this parallel evolution. Kind of like flight. Flight had to evolve 4 different times, right? You got flying reptiles, you got flying mammals like bats, you got flying birds, and you got flying insects. None of those guys copied their homework from each other according to evolution. They all developed flight independently of one another, which I think is hilarious. Like, as unlikely as it is to evolve the ability to fly, it happened 4 times. Well, here we have the same problem, the same parallel evolution we see in the eyes. These guys have their own system, totally different from any other type of eyesight on the planet. The insects have their own type of eyesight, and we have ours. And you could also argue that the cephalopods have a totally different eyesight system compared to land animals. Okay? So 4 different times eyesight is as unlikely as it is to evolve once. Apparently, it evolved 4 different times. This is bizarre. Anyway, so scientists have tried to say the deposition rate of each of these layers is 1,500, 2,700 years per foot. Some say it takes hundreds of thousands of years to lay down an inch. Okay, well, again, this is not something we find, out in the little place I like to call the real world. Now, here what we're looking at is a deposit of fossil jellyfish. Okay. Now, they are not what we call a true jellyfish. Maybe you've seen box jellyfish, because it is extraordinarily venomous. This is the same kind of organism as they are. Okay? A true jellyfish has an umbra It does that little through the water. These guys do that, but they don't have a separate umbra from their tentacles. Anyway, so long story short, they're considered more primitive, which I think is hilarious because hey, we got some swimming around in the ocean right now. They're just like these guys. So speaking of stasis in the fossil record, I want to go. When I get to heaven, I'm gonna have a little video recorder. I want to go back in time to when the scientists discovered this deposit of jellyfish, because he was taught his whole life that fossils take millions of years to form. Oh yes, because down at the bottom of the ocean, the rock layers are building up very, very slowly, don't you know? So fossils can only form very, very slowly. And then he gets out in the real world after having been educated in college for all these years, right? He's got his doctorate and all that. He goes out and finally gets a shovel. Okay, they let you have a shovel after a while, and goes down, digs around, finds a huge deposit of fossil jellyfish. I think it's in Australia. I'm gonna see the look on this cat's face.
I want to know if we will truly remember these things, because everybody says, "Oh, when I get to heaven, I'm gonna have so many questions for God." No, we're not.
I think there's a lot that you're gonna be like, okay, you know what? My questions are irrelevant at
Yeah.
this point. But I think I'll still want to see the look on this guy's face when he realizes he's been lied to his entire life, coming face to face with a literal mountain of evidence to the contrary. And this guy is having a bit of a crisis, right? In war, we say it's a significant emotional event, right? When you get shot at. This guy, shots fired, okay? He has come face to face with the fact that these jellyfish were buried basically instantly. He wrote an article about it. He's like, look, this formation, he describes how huge it is, hundreds of feet in both directions, dozen or 15 foot thick or something like that. Like there's a whole thing had to be created in less than 24 hours. Because the jellyfish is made mostly of snot, right?
Yeah.
I mean, it's fancy snot, but it's snot, right? And they wash up on the shore. They sort of think they're like, oh, we're screwed now, right? And they decompose quite rapidly. And they're basically not going to look like that in less than 24 hours. How are you going to fossilize all these jellyfish? You've got to form those layers quickly. Well, I can tell you're not impressed. I'll give you another example of evidence to support my position, which is the fossil layers are laid down fast. Okay, I have here what we call a polystratic fossil. Now, that's the ball game right there, folks. You want to believe the fossil layers form slowly over millions of years? Well, may I point out to you that the rocks are crying out here. Okay, you've either got to give up your silly notion that rocks form slowly over millions of years, or you've got to say that this is one old tree. I'll point out that we have here in the lower section, right underneath the hammer, part of the root ball. Okay, and we're looking at what 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, maybe 34 different layers of rock. I got this crazy idea, boss. I think that tree was laid down at the same time as all those layers. Well, now you got a little bit of a problem as an evolutionist, because polystratic fossils are so common that we have a special name for them. Polystratic, meaning many layers. Okay, we don't call them many layer fossils because that just sounds like a cake, I suppose. We should call cakes polystratic.
What if it's a
To open a
similar
bakery, Cartwright's polystratic cakes. Yeah.
The cake fossils.
Nobody wants to eat fossils. Anyway,
Some people probably.
so this is not even the largest or the most common type of polystratic fossil. Excuse me, trees are the most common type. There's ones out there that go through 50 or 60 layers. There's a polystratic tree that goes through 2 coal seams. Its root ball is coalified in one seam. It's petrified from the trunk up to the branches, and the branches are in another coal seam. So there's
get qualified.
very carefully. So the thing is, in the world, there are 80 layers of coal. Okay. 80 different layers. Some of them are dozens, or I believe they found one that was 400 feet thick. There's a lot of coal out there. If you ever go up north, you'll run into, well, don't run into the trains. You'll discover there's a lot of trains up there carrying coal all over the place. They burn it for electricity. We don't get to see how much energy we actually use because ours is all piped in. So natural gas is the most common way that we make energy. That we generate electricity. We can't create energy. Anyway, so where do we get all this coal?
Born from we have millions of years.
Okay, well, you got yourself a little bit of a problem. Let's see if I can look up that tree for you real quick. Josh, bear with me and we'll see if we can get the internet to work with us. Open a new share over here. There we go. Let's try images. Maybe we can find it. Ah, here it is. That's a really small one. I don't know how you can see that. Rocks don't photograph very well. I don't know if you've noticed. Ah, here it is. Here it is. Here it is. So here we see the root ball down at the bottom. This is in a coal seam. Up above that, the trunk is petrified until you get up to the top, which is also in a coal seam. And again, I don't know if you can really appreciate the nature of the fossil there. Again, we do find some places where fossilized polystratic trees are so common that they interlink every single layer in a mountain, for example. You know, again, you might say that that is a mountain of evidence that all of this stuff was laid down at one time. Okay. But I can tell you're not impressed. Okay, I got another one for you.
So would the tree getting coalified work the same way as the bones getting enriched in like copper?
No, in that case, we're talking about carbonization rather than petrification.
So it's like the pressure.
The heat and pressure turns it into coal.
Yeah.
And as we discussed earlier, you can do this on demand. You don't have to have millions of years to turn something into coal. You need a lot of heat and a lot of pressure. In South Africa, for example, they don't like importing oil, but they don't have any oil in the country. So they do have a lot of coal, and they just turn their coal into oil using the Fischer-Tropsch process. You can use heat and pressure, and you can convert any carbon-based molecule into oil and natural gas. And if you switch up your process a little bit, you can turn most of it into coal if you want. Okay, carbon. This is carbon, so you could take this textbook and turn it into coal if you want.
Is plastic carbon?
Plastic is made from oil, so it is 100% carbon. So most of the stuff that you throw away, plastic, cardboard, paper, wrappings, etc., you could turn into oil if you want, instead of burying it in some kind of landfill somewhere.
Wait, but couldn't it get couldn't it get pressurized, like in?
Oh, in the landfill?
In the landfill.
Probably. Yeah. So the landfills that we have had going for dozens of years, or in some places hundreds of years. We bury them over. We notice there's methane gas coming out of them, which is natural gas. And this really freaks us out because every once in a while one of them blows up, which is a problem. Okay, you don't want your landfill blowing up. So what they do is they drill them for natural gas. They like somebody call an oil company. Okay, we accidentally. They're like, oh yeah, well, so they drill a whole bunch of little pipes in there, and they collect all that natural gas out of there, and they sell it for energy. But you don't have to bury it in the ground to do that. It'd be way more efficient putting it into a thermal depolarization machine and doing it that way. Now, I have done a Google search here for a fossil clam. Okay. Do you notice anything about these guys? Let's look at a couple of hundred of fossil clams and see if we can determine any common characteristic what jumps out at you. They look like clams, right? Is this what you find on the beach? I mean, if you bet, they're all commons. May not have been to the beach very often, but you go to the beach, you find a shell. Does it look like that or no?
No.
Yeah.
What's shiny?
What do you notice about these guys? They're all in the closed position. Wait, what? Is that what you find on the beach?
You can.
I
It takes a
have.
while.
Every once in a while you might find one. How come all of these are in the closed position? The vast majority of the shells you find
So
are
they're
marked
protecting
out.
themselves from the.
They're
And they got
they're
very,
still
very quick.
alive.
Is there like a muscle?
Yeah, there's two muscles on either side of the hinge there that hold it in the closed position, right? So what can we say about clams that were fossilized in the closed position?
They're really good.
They were still alive when they were buried. I can tell you're not that impressed. Okay, check out this guy over here. You notice what happened to him?
He's open.
He got buried
Oh.
before he could close. Is this freaking you out? Because it's freaking me out a little bit. This guy got buried at 100 miles an hour.
Oh, yes, boys and girls, fossils take millions of years to learn paradise.
Really? This guy was fossilized before he could close.
Mid chew.
That's what they look like in out in the ocean, right? They're filter feeders. Here's another one that was fossilized before it could close. $20. Pretty common, right? Okay, I can tell you're not impressed. All right, I'll tell you what. There are fossils of fish eating fish. Now, when I showed this to my brilliant professors, who are all evolutionists but all Christians, okay, I know. I showed them. I had a PowerPoint I was showing them, and I showed them this particular picture, which I thought was the coolest one. If I'm just making a PowerPoint, I'm going to pick the coolest one and put that. Well, they were like, Cartwright, isn't it possible that the small fish was fossilized and then the large fish was fossilized on top of it with its mouth open?
Yeah.
The resistance you have to information is impressive.
Anyway, so I did a Google search for a fossil of a fish eating a fish, and they got really, really quiet because I was trying to tell them something they didn't want to hear, which is, you're not a geologist, you're not a paleontologist, or you would know that fossils do not form slowly over millions of years. There are literal mountains of evidence to the contrary. That dude was fossilized in the middle of lunch.
Or on top of it.
Or on,
With his mouth
with his mouth open. I suppose there's another way to interpret the
Maybe they were
information.
just playing
Perfect. It's
tag.
like this right
And they were
here.
chasing
They're
after
playing
each
That's what
other.
that's what they're doing.
Shot, and they went into it.
Yeah, they were just having a good time. They were having a good conversation.
Well,
Even though Tammy didn't agree.
Yeah.
So how long does it take strata like this to be laid down? Not very long. Fish are fossilized in the middle of eating fish. Now,
This has forced the paleontologists and the geologists to admit that the individual layers of rock formed quickly. How quickly? Maybe 200 miles an hour. Okay, very fast. All right, and they say that the time necessary to make evolution palatable is between the layers. Now, Dr. Don Patton would say, where there is no evidence, which I think is genius.
Well, let's have a look, shall we? Between the layers of rock. It has been said by ignorant people that a perfect cure for an evolutionist, or excuse me, for a creationist, is to take a trip down the Grand Canyon. Okay? And what you will discover if you go to the Grand Canyon, oh, here's a beautiful picture of it. One of the most striking features of it is this massive band of what we call the red wall. Okay, the Mississippi red wall. Why Mississippi? Because it is the Mississippian layer. Okay, maybe this is a better picture of it. The Mississippian red wall sits on top of the Cambrian layer here, and again, rocks are a little bit hard to photograph, so maybe we can find. Well, yeah, that's an interesting picture. Okay, the Cambrian Muav there is directly in contact with the Mississippi red wall.
When me and my family went to Grand Canyon, we got there completely filled with fog.
Oh, geez, that sucks. Oh, here we go. There we go. Hang it.
Fog vision.
So is this a problem for
The evolutionist. Well, yes. A couple of things to note about this particular picture. First of all, the scale that you're looking at. The Cambrian in this, I don't know if you can see these little green specks. Do you see that?
Yes.
Those are trees. Practicing for church. Those little green specks up there are trees. The section of rock we're looking at is probably 2,000 feet from the top of the picture to the bottom of the picture. Okay, so the scale on this is insane. Okay, what do you know about Cambrian? Well, it's the first layer in the fossil record. But cool. All right. So, what about the Mississippian? Well, isn't there a little alarm bell going off in your brain somewhere? Maybe, maybe not. There's 3 missing layers, Cartwright. Oh, yes, you're so observant. Where's the Ordovician, the Silurian, and the Devonian?
They don't.
They're
look
They,
like-
invisible.
they don't exist in the Grand Canyon.
They don't look like they're there to be Mr. Cartwright.
I don't see them. Well, that's because they're not there. The Ordovician, Silurian, and the Devonian are gone. Okay, well, this is a problem for you. I know you've been clinging to this idea that the world is millions of years old and evolution is, laid down all these rock layers for millions of years. Here's the problem. The Ordovician, the Silurian, and the Devonian is about 220 million years worth of time. So, if you're an evolutionist, what you have to do is say, okay, so here's the thing. One day, Trilobite was walking around on the bottom of the ocean, and then it got buried in like 1,000 feet of mud.
Instantly.
Now, keep in mind, it's fast enough to fossilize its tracks. Okay, we find fossils of Trilobite tracks out there. Okay, so we laid down this massive layer of rock. Now, keep in mind, sure, it's 1,000 feet thick, but it's hundreds of miles across. This thing covers 1/3 of the United States. This makes Mount St. Helens look like a walk in the park, like a trip to the Vienna Boys Choir. Like this, that is nothing. I laid down what 600 feet of rock in 4 hours over 3 or 4 square miles. This is an event that would shake you to your core. Right? This is the worst catastrophe that has ever happened on the face of the earth, right? It happened so fast, it preserved little ocean bugs at the bottom of the ocean, froze them in their tracks. Okay? Fossilized clams before they could close. All right? And then, for about 200 million years, nothing happened. Because you notice, there's no erosion between those layers. It's a perfectly straight, smooth line. We call that a paraconformity. Paraconformities occur where there should be erosion because there's a missing time in there, but there's not erosion. There is erosion in between two layers in the Grand Canyon. We call that the Great Unconformity. Not a good name for it. I would like to call it the only unconformity. Where's your erosional barrier here, bro? You got 200 million years of time. You're telling me that for 200 million years, there was no soil layer, there was no erosion, there was no plant life, there was no root penetration, there were no meteor impacts, there was no animals walking around. Nothing happened for 200 million years. And then the Mississippi Red Wall got laid down. Now, folks, I'm trying to tell you, that was even worse than the Cambrian Muab. Whatever laid down the Cambrian Muab, Mississippi Red Wall was even worse because it's even thicker. And what do we find in the Mississippi Red Wall? Well, we find clams all over the place, fossilized in the closed position, some of them with their mouths still open, right? We find fossils of fish eating fish. We find fossils of coprolites. Coprolite is dinosaur poo, okay? We find fossils that obviously were formed rapidly. So what kind of an event are we talking about here? What kind of a marine catastrophe could lay down 1,000 feet of rock over hundreds of square miles in that kind of speed and yet cause no erosion to the layer beneath it? I mean, if you want to believe that, sure, knock yourself. I can tell that you're not impressed. Okay, all right. I got one more for you.
Better impress us.
I'm just gonna, I'm gonna keep going here. Okay. Here's the thing. It's not just that the Ordovician, the Silurian, and the Devonian are missing. That's not the only problem. There's another problem here. This is not just a paraconformity, ladies and gentlemen. These guys are interbedded. Okay? The bedding planes are mixed up. I mentioned this to my college professors. I was like, you understand that the bedding plane between poor kids allergic to science. So the Mississippi Red Wall and the Cambrian Muab they go back and forth. Okay, so you have to believe, if you're an evolutionist, that you're starting over here somewhere, you snap forward. What? I told you guys I got to bring my big knife. You snap forward 200 million years, and then you go backwards. See this right here? This is Muab again. Okay. Then you go backwards 200 million years, and then you snap forwards 200 million years, and then right above that, right over here, I don't know how well you can see that, that's Muab again. Then you go backwards 200 million years, then you go forwards. This is Red Wall up here, and then you go back. Again, that's like 10 foot thick, right? 20 foot thick. Then you go backwards to Cambrian again, and then you go forwards to Mississippi Red Wall, and then you go backwards to Cambrian, and then you go backwards and forwards and backwards and forwards 7 times. They must have, right? And nowhere do we find hide nor hair of the Devonian, the Silurian, or the Ordovician. Interbedded layers are laid down at the same time. They're contemporaneous, we call that. Nicholas Dino, the guy who went out and actually did the first surveys of stratigraphy, he actually wrote a textbook on stratigraphy that is still used in geology today. In the original edition, you will see on the front page, dedicated to the proof of the Great flood of Noah. This guy was a Christian, and he went out here and see these layers that are interbedded.
You got my
They-
attention.
They were laid down at the same time, yo. You're looking at a mile of rock that was laid down in one event that covers a third of the continent. You're looking at the judgment of God. You think God doesn't take sin seriously? We treat it so casually, don't we? What kind of an event was this? I mean, you grew up in church thinking, it's like, oh, it rained and all this stuff. And he was on the ark and all the animals, they were petting the cows and stuff. And you're like, that'll be okay. No, that's not what was happening. No one was freaking out. He was losing his mind. Everybody was like, nothing survived this. Okay, yeah, some things survived. They got out of the flood. They were just like, dude. What was that all about?
We got thankful that we got on that boat.
I think we should build an altar and thank God, like right here, okay?
They started running.
Do what?
So the goats probably ran away then.
Yeah, that's probably what happened to the goats. Maybe that's their problem. So here's the deal, guys. There are mountains of evidence to support the idea that these layers were laid down at the same time. They don't represent millions of years. And you don't have to have some kind of rocket engineering degree to figure this out. Okay? You can go to any layers of sedimentary rock and you will find that almost none of them have any signs of erosion between the layers.
I do wonder why, even if it was sprayed instantly, why did it form layers? How did it not?
So we'll do a lab. So
We're doing a lab.
Not today, but we'll do a lab where we go out to the real world outside. I want to put some sunscreen on. And I'm just teasing. We'll go outside and dig a hole. We'll get some leaves and stuff, and we'll put everything in this little bottle and dirt, sand, ground there. We shake it up, and in about a week, you get about 5 layers out of it.
Yeah. All right.
Because everything sorts itself out based on its density.
Yeah.
So you get the silt at the top, the clay at the bottom, the sand, the gravel. It just sort of, it sorts itself by its density. Now, the crazy thing is, if you have two particles that are very close in density, they will still sort themselves into layers. We used to actually just sell desktop toys that would do this, and you flip them over and they go, and they form 5 or 6 layers in about 10 seconds. Okay. So rock layers do this, and sometimes we see a repeat of sand, silt, clay, sand, silt, clay. So we see that kind of a pattern throughout the fossil record, and again, usually only 2 or 3 times.
That makes sense.
Because you only got 5 or 6 layers. Okay. But that's kind of what you're looking at here. You got sandstone, limestone, and shale. Sandstone, limestone, shale. Sandstone, limestone, shale. All over the place. Okay. And with some some rowdiness and some excitement thrown in by the igneous rock every once in a while. We see some of that, some lava in there. That's a volcanic intrusion. That was particularly nasty part of it. You did not want to be here, okay, when this was going down, right? That's why I'm a Christian, by the way. When I'm not making this up. College was kind of a dark time for me spiritually, okay?
Tries just to beat away at your
It
Christianity.
really, really does. And even, I thought going to college would be like BBS on steroids, right? I was going to get all the equipment that I needed, this training to go out there and fight about. College was the battle. Anyway, so my professors were determined to convert me over to being an evolutionist because, how could anybody take science seriously and still be a creationist, especially a young Earth creationist? This is why. This is the thing. I mean, I'm talking about scientists who, been teaching for 40 years, right? And they knew so much more about me than anatomy. They try to argue the intermediate forms and all this stuff. And I was just like, look, I don't know who to trust, you or people that have trained me up. I'll tell you what. Why don't you try and explain terra conformities to me? Can you do that? Can you explain the interbedding here?
You did not go to college for this, Mr. Cartwright.
Well, here's the thing. When I mentioned this, my professors were like, oh, well, the rock layer probably got flipped over. That was their explanation of interbedding. No, they had no explanation for paraconformities. Their answer was, oh, I'm not a geologist. Really? Maybe you should talk to your geologist friends about this because they don't have an answer for it. Okay. The original geologists were all creationists, and there's a reason why. Okay.
Because the evidence is overwhelming. Well,